Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter metals and non-metals 10 Cbse. So let's see today's topic. So extracting metals towards the top of the activity series. Alright. Now if you see on the top of the activity series, we have got metals like sodium and potassium. Okay. So these metals high up in the reactivity series are very reactive. They are very reactive. If we expose them to atmosphere, they catch fire immediately. They cannot be obtained from the compounds by heating with carbon. So earlier what we have seen carbon, right? What it was doing reduction. Okay. So carbon cannot reduce the oxides of sodium, magnesium, calcium, right, to the respective metals. Why? Because these metals have more affinity for oxygen than carbon. So the affinity of this metal toward oxygen is more than carbon. So what we need to do? So what we need to do is that the metals are obtained by electrolytic reduction. Now what is electrolytic reduction? Here you see this is the electrolytic reduction process as such. For example, sodium, magnesium, calcium are obtained by electrolysis of their molten chlorides. Molten chlorides, the liquid of that. For example, we have got sodium chloride, right? Okay, the liquid form of sodium chloride is called as the molten form. Okay, the metal deposited at the cathode. Here you see the metal deposited at the cathode. Okay, the negatively charged electrode is there. Cathode is a negatively charged electrode, we all know. Okay, where chlorine is liberated where at anode. Okay, chlorine is liberated at anode and sodium is deposited at cathode. Here you see sodium is getting deposited at cathode, right? So this is how we see the reaction at cathode. What is happening? Sodium ion, it's accepting one electron and we get sodium metal. Chlorine, you see chlorine is being released at anode like this way. So this is how these metals at the top of the activity series are extracted. So here you see example of aluminium being extracted by the electrolytic reduction of aluminium oxide, right? Okay, so, here you see the electrolytic reduction process. Cathode, what is happening? Aluminium ion, which is accepting 3 electrons, and we are getting aluminium here, right? Here you see the graphite, the anode is there, okay, and here you see the graphite lining, cathode is there. Okay, so this is the steel tank, and what we get a molten aluminium from down, right? So this is the reaction, anode reaction and the cathode reaction for extraction of aluminium. Now you see that the metal produced by various reduction processes are not very pure. Now we know that we have got metals, right? So that we have extracted from metals by the different process, like we have reduced it and we have got the metals. But the metals what we have got is not 100% pure as such, right? They contain what? They contain lot of impurities with them. So that has to be removed. So what method we need to use? So they contain impurities which must be removed to obtain pure metals. Now the most widely used method for refining the impure metals is electrolytic refining. Now what is electrolytic refining? Is nothing but we have electrical cell and through that we are refining these metals. Let's see how we are doing this process. So electrolytic refining happens with metals like we have copper, zinc, right, silver, so that these are refined electrolytically. So in this what happened? In this process what we see is that impure metal is made as anode, right? Here you see, so what will happen? Impure metal is made as anode. Okay, here you see impure metal is there, it is made as anode. And a strip of pure metal, right? Here you see a strip of pure metal will be there. It is made as cathode. Okay. So this is my cathode, right, which is a pure strip, a strip of a pure metal, right. Then what happens? A solution of metal salt. For example, we are doing electrolytic refining of copper. So what metal salt you will take? You will take copper sulfate, right? Accordingly, you need to take. If we are doing electrolytic refining of copper, we need to take copper sulfate as such, right? Is taken as an electrolyte. Now then, the current is passed through the circuit. Then what happens? The pure metal from anode dissolved into the electrolyte, right? Okay. So what will happen here? You see, okay, an equivalent amount of pure metal from the electrolyte is deposited on the cathode, right? So what you see is that anode we have got the impure metal. Okay, so what happens from this impure metal? The pure metal comes out, right? It is coming out, and then it is going towards the cathode. Cathode, which we know that is nothing but it is a strip of a pure metal as such, right? So what is happening is that an equivalent amount of pure metal from the electrolyte, this goes into the electrolyte, this goes into the copper sulfate, and this copper is getting deposited on this cathode, right? The soluble impurities go into the solution, the impurities which are soluble, that will go into the solution, and what will happen? The insoluble impurities settle down as what? As anode mud. Okay, a very simple process where you are taking anode as what? A impure metal, and a strip of a pure metal as cathode, right? And the electrolyte has to be taken as that of a metal salt. Okay, so we are taking it. Then as soon as you pass the electric current into this, what will happen? Anode which has the impure metal is there, right? From that the pure metal will come out. Okay, and that will displace this what? The copper from the copper sulfate solution here, and this copper will be deposited on the cathode, right, which is nothing but a strip of a pure copper. So this is how this electrolytic refining will work. Now let's see what we understand by corrosion, right? So we have seen that we have the silver articles which become black after some time when it is exposed to air. Why it happens like that? This is because it reacts with what? It reacts with sulfur in the air to form what? To form silver sulfides. We get what? Silver sulfide. And that's the reason you see the blackish color is there on the silver. Copper, if you see, copper reacts with what? It reacts with moist carbon dioxide from the air. And slowly it loses its shine. Okay, right, and it gains what? It gains a green coat on it. Now this green substance is nothing but it's copper carbonate what we are getting. Okay, that's the reason the greenish layer what we see on the copper after some times. Now when you see iron, when exposed to a moist air for a long time, it acquires what? A brownish flaky substance called as rust on it. Now let us see one activity, right? What we need to do in this activity is that we need to take 3 test tubes and place clean iron nails in each of them, right? And label this as what? A, B, C respectively. Then what we need to do? Pour some water in test tube A. Here you see what we have done. We have posted some water in test tube A, right? Then what we need to do is that then in test tube B, what you will do? You will put this iron nails, and along with that, you will put a distilled water in test tube B, right? And add 1 ml of oil and cork it. Okay, the oil will float on water and prevent the air from dissolving in water. Okay, so what is happening? Air will not pass through it. Now what we need to do that in the third one. Okay, third test tube C, Put some anhydrous calcium chloride in test tube C and cock it. You know that anhydrous calcium chloride will do what? It will absorb what? It will absorb the moisture, right, in the test tube. Okay, and let us leave this test tube aside for few days. What we'll observe in test tube A, what we'll see that the iron nails will rust, right? And in test tube B and C, what we see is that the nails are not getting rusted, right? Okay, the nails are not getting rusted. Now, what is the reason as such? In the test tube A, you see it is getting rusted. In test tube B, the nails are exposed only to what? Only to water, right? The distilled water what we have put. And in test tube C, what we are seeing, they are exposed only to dry air, right? So what we see is that the iron nails are getting rusted where you see where we have got air and water as such. Okay, that is the moisture is there. Okay, moist air is there. In that condition, these iron nails are getting rusted. Okay, so then let's see what is this corrosion is all about, right? The rusting of iron can be prevented by how? So see here, you see big ships and all this metal parts are there. After some time, what we see, they are getting rusted. Okay, tremendous amount, huge amount of money is spent to prevent rusting every year. Okay, throughout the world. So how can this rusting be prevented? The rusting of iron can be prevented by painting, can be applied to painting, by oiling it, by greasing it. We can galvanize it, we can chrome plate it, and anodizing can be done, or making alloys. So we are going to see this one by one how this thing happens, right? So let us see the technique called as galvanization. Now galvanization is the method of what is protecting the steel, okay, protecting steel and iron from rusting by coating them with a thin layer of zinc. So what we are doing, we are applying a thin layer of zinc on the iron, right? So the galvanized article is protected against the rusting even if the zinc coating is broken. Why so? Zinc is more reactive than iron. Okay, so what it will do? So it can easily get oxidized, right, before iron. So when this zinc coating breaks, the zinc continues to react and get oxidized, right, protecting the iron object inside. So this is how the galvanization works. So student, I am sure you have understood today's topic. So kindly like, share and subscribe my channel Kishore Sir Ki Pathshala for more informative videos.